Number 6 on the QR code review wants us to solve this quadratic using the quadratic formula and just leave your answers in exact form. Okay, so the first step you gotta do, like we said before, tell me what the three values of A, B, and C are. So A is worth 3, B is worth -2, and C is worth 5. Then you gotta tell me the discriminant. So let's go B squared minus 4AC. That's our discriminant setup. That's -2 squared minus 4 times 3 times 5. That's 4 times 3 is 12 times 5 is 60. So 4 minus 60 is -56. So that's a negative number. So therefore we know there's going to be two complex solutions. Okay, and then step 3 is go ahead and figure out. So -b plus or minus the square root, b squared minus 4ac all over 2a. So then x is going to be the opposite of b, which is 2, plus or minus the square root of -56, and then all over 2 times 3 is the number 6. So now you kind of have to deal with this square root of -56. So I'll bring it over here for you. We know it's going to be square root of -1. I'm looking for the largest perfect square that's a factor of 56. So it turns out 4 times 14 is 56. So I'm going to go a 4 and a 14. So the square root of -1 becomes I, the square root of 4 becomes 2, and the square root of 14 just remains the square root of 14. So now this whole thing can be rewritten as x is equal to 2 plus or minus, it's customary to put the number in front, so 2i rad 14 all over 6. Now what I want you to do here is to see if you can pull out a common factor from the top, which you can, and that would be a 2. And you'd be left with 1 plus or minus I rad 14 all over a 6, and then cancel these, simplify. So that becomes a 1, that becomes a 3. So your final answer is x is equal to 1 plus or minus I rad 14 over 3. So that's what you're looking for when you're all said and done. A lot of students have trouble with this part, but you gotta be able to break it down and just look for those factors that are perfect squares.